Yes, Vanshika, now you may proceed.
Okay, sir. A very good afternoon to my dear teacher and to all my fellow mates. My name is Vanshika and I welcome you all on the behalf of Dia Delhi team in a today's science and tech session by our very own Neeraj Nachiketa sir. I'd like to begin our today's class with a positive thought that says, be at war with your vices and peace with your neighbors and let every new day find you a better person. Thank you and I'd request sir to please take over from here.
Okay, thank you. Thank you, Vasika. And so we'll start with the topic there. So yesterday I have already covered Gaganyaan mission, and I said that Vyom Mitra. Now, just a few days back, it was in the headlines, right? It was in the news. So I would just like to add something, and then I'll go to the respective topics one by one. Let me just go into that. Now, this is what you can see, right? ISRO's female robot, humanoid robot, right? Now, since next year, 2025, we are going for human space flight Gaganyaan mission. Before that, we will carry out unmanned missions. So without human being, we will do the same kind of a mission, right? In that context, Vyom Mitra will also accompany there. What is given here? That Vyom Mitra to visit space ahead of Gaganyaan mission. And she is equipped with all life support system, which the astronaut will require when they will go to the outer space. So now here we see here this one, right? So India's Jitendra Singh, Mr. Jitendra Singh, who is a science and technology and also Department of Space. He's looking into Department of Space, DOS, and Department of Atomic Energy. He just announced that Vyom Mitra, right? She will go for the Gaganyaan mission prior. We'll do all the testing part of it. Then you can see here this one. Now, from the name, you know that Vyom means space. Mitra means friend. Right? That's what the name has been given. Vyom Mitra. And our astronauts, 3 Indian Air Force astronauts, they are called Vyomnauts. Like Russian called cosmonaut. Americans call astronaut. Right? India will call Vyomnaut. But this is Vyom Mitra here. Then again, another thing here. She has a monitoring capability, right? She has alert systems, warning system. She can give warning also. And again, all operating system of the crew module. I mentioned that crew module will be there. So Vyom Mitra is capable of dealing with those crew module. At the same time, Vyom Mitra will also be having the voice, can talk just like a human being, right? Based on that AI system, right? So same as human being, as a real human being will work in the outer space where I have already said microgravity, where the gravity is very, very minimum. Same way this Vyom Mitra will go there, will again stay there, and will get all parameters, all data from this mission there, right? So adaptation part will be tested there. So scheduled is that quarter of the current year. Now we are in 2024. So now we are in the month of February. So next month, March, right? This will be given here. So given here third quarter. Third quarter means October, November. In the month of October and November, Gaganyaan mission, prior Gaganyaan mission, that means ISRO is going to send same mission. We'll use same kind of thing to go into the outer space, remain in the space and come back. Crew module, the same crew module, but the crew module will have Vyom Mitra. Inside the crew module, Vyom Mitra will be there. So we have scheduled for October, November. And then 2025, the three human astronauts in the crew module will go to the outer space. That's what we have planned for it, right? So this is what you come across. So there's one thing which I would like to add here. Recently, another thing was this one, Bharti Antriksh Station, right? Which is going to be constructed in multiple phases, right? So if you look at here, one is this one, right? So Bharti Antriksh Station, BAS, right? This is what short form is, acronym is BAS. So BAS is what? Expected to weigh around 25 tons. 1 ton is equal 1,000 kilogram. So 25,000 kilogram That will be the part of, and it will be initially consist of that one, right? So if you look at the timeline, so I've already mentioned that we are going to start from 2028, and by 2035, we will construct the space station. This is the design of this one, right? Multiple phases we are going for it, correct? So now you see that this one, ISRO, including module types, everything will be there, right? So here, command module, habitat, where astronaut can live in there, propulsion system, and docking port. Let's say when the rocket will go and can dock, that will be there. And we have planned for 2028, and we'll use GSLV Mk3, LVM3 rocket to take first module to the outer space. So this is what Dr. K. Somnath, he announced during a conference. We are going for such kind of a mission there, right? So that is what I wanted to add. That's what I've done here. And we'll go into the topics one by one. So what is the first thing which I want to add here? We are going to discuss about NISAR mission. We'll discuss about NISAR, right? NASA ISRO synthetic aperture radar. That's what our first topic is there. And it's going to be a very important mission for India. After Aditya L1 mission, NISAR will be the really very, very important for that. तो ये चीज आपको ध्यान रखना है कि जो भी ऐसे मिशंस हैं जो पिछले 5-6 सालों से चर्चा में है, जहां पर क्वेश्चन पूछा जा सकता है, तो आपको उसके बारे में पूरी तरह से पता होना चाहिए, है ना? बाकी चीजें यूपीएससी के ऊपर है कि यूपीएससी क्या क्वेश्चन पूछेगा, वो कोई नहीं कह सकता। हाँ, लेकिन आपको तैयारी आपकी होनी चाहिए, आप यू शुड बी अवेयर ऑफ इट। तो हमारा जो अगला नेक्स्ट मिशन है निसार है, नासा इसरो सिंथेटिक अपर्चर रडार, ठीक है? तो आई विल बी गोइंग टू दोस काइंड ऑफ टॉपिक देयर। तो लेट अस जस्ट take you to the first image part of it, how it looks like. Then we'll see the mission part of it. So you can see the photograph here, है ना? मैं आपको photograph दिखाता हूँ, and then we'll go into detail part of it. This is how it will look like. What do you see this image here? This is a satellite, and it carries a radar. What you can see, this is a radar, radio detection and ranging, है ना? इसको कहते हैं सिंथेटिक अपर्चर रडार, सार, है ना? ये रडार यहाँ पर है, और ये सैटेलाइट है। इसको जॉइंटली इंडिया और एंड यूएस, है ना, इसका नाम है नासा इसरो, अमेरिकन स्पेस एजेंसी एंड इंडियन स्पेस एजेंसी टुगेदर हैज बिल्ट दिस पर्टिकुलर सैटेलाइट, है ना? और ये किस तरह सैटेलाइट है? इसको कहते हैं अर्थ ऑब्जर्वेशन, अर्थ ऑब्जर्वेशन, व्हाट इज कॉल्ड रिमोट सेंसिंग, वी कॉल इट एज अ रिमोट सेंसिंग। इसको हिंदी में कहा जाता है दूर संवेदी, है ना? हिंदी में दूर संवेदन, रिमोट सेंसिंग शब्द का प्रयोग किया जाता है। तो दूर संवेदी उपग्रह, इंडिया के पास ऐसे बहुत सारे सैटेलाइट्स हैं, कार्टोसैट, रिसोर्स सैट, ओशन सैट, बट व्हाट इज वेरी इंपॉर्टेंट थिंग, इट्स अ जॉइंट मिशन. India and US both are coming together in a single mission to carry out this one, right? Now what is important thing here, that contribution part, each of the agency का क्या contribution है, what will be the contribution here? The first thing is that this radar will work with some frequency band. कोई भी डाटा जो होगा, यहाँ पे फ्रीक्वेंसी होंगे, फ्रीक्वेंसी बैंड होंगे, और एक तरह का इंस्ट्रूमेंट होता है पोलरीमीटर. व्हाट इज द इंस्ट्रूमेंट? पोलरीमीटर, है ना? स्पेक्ट्रोमीटर, पोलरीमीटर, दे ऑल वर्क विथ रेडिएशंस. तो यहाँ दो तरह के पोलरीमीटर होगा. वन विल बी यूजिंग एल बैंड, अनदर विल बी यूजिंग एस बैंड. फ्रीक्वेंसी रेंज पे काम करेगा. एल बैंड विल बी गिवन बाय नासा, एस बैंड विल बी बाय आईएसआरओ, ठीक है? एल बैंड का जो पोलरीमीटर है वो नासा के द्वारा बनाया गया है, एस बैंड का जो पोलरीमीटर है वो इसरो ने बनाया है. ये पहला कंट्रीब्यूशन है. दूसरा ये है कि इसका लॉन्च जो है इसरो करेगा श्रीहरिकोटा से. You all know that Pulikat Lake, Andhra Pradesh, we have Satish Dhawan Space Center. So we are going to use GSLV MK2 Mark II. अब कैसे पता चलता है जीएसएलवी मार्क 2 है या मार्क 3 है? जब आप न्यूज में पढ़ते कैसे पता चलेगा? अगर कोई जीएसएलवी के साथ लेटर एफ होता है तो एफ लेटर दैट शोज जीएसएलवी MK2 Mark II which can carry 2250 किलोग्राम सैटेलाइट जो है, तो वहां हम यूज करेंगे. तो दिस इज व्हाट यू फाइंड हियर. नासा इसरो कम इन. दिस इज रॉकेट. दिस इज मार्क 2. मैंने बताया था क्लास में कि इट यूजेस द 4 स्टेप ऑन मोटर्स. इसमें 4 ऐसे स्टेप ऑन मोटर्स को यूज करते हैं. और वो क्या होता है? लिक्विड फ्यूल होता है. जीएसएलवी MK2 में, जो मार्क 2 में. देन पहला स्टेज क्या होता है? स्टेज 1. पहला स्टेज जो होता है ना, स्टेज 1 जो है, स्टेज 1 दैट इज अ सॉलिड. Then there is a second stage, stage 2, that is liquid. And I have told you in the classroom, the last upper stage, there's a cryogenic, liquid hydrogen with liquid oxygen, cryogenic stage. That's the stage 3, right? वहां अपर स्टेज में होता है. इसको कहते हैं सी 7.5 टन होता है. तो वी आर गोइंग टू यूज GSLV MK2 to launch the NISAR satellite. And this box here, NISAR satellite will be kept. This ये जो spacecraft है, that will be kept here. Right? That's what we have planned. And what is our plan there? Our plan is that we will be using this Mark II and put in an orbit. You see the orbit here. What is SSPO? SSPO stands for this one. Sun synchronous polar orbit. Sun synchronous polar orbit. You can see this is the SSPO. Will keep the NISAR. NISAR will be moving here with this radar. It is going to carry this radar. It will move in this orbit. This is NISAR. See, always remember that Earth observation, remote sensing satellite. Earth observation, remote sensing satellite, they suitably use the polar orbit. And you know what is sun synchronous? मैंने आपको बताया था sun synchronous क्या होता है? That is in with respect to sun. सन के डायरेक्शन के अकॉर्डिंग सैटेलाइट का मूवमेंट होता है, राइट? इसी को सन सिंक्रोनस कहा जाता है. और ये कैसा ऑर्बिट है? आज का क्लास बहुत इंपॉर्टेंट है. बहुत सारी चीजों को जो हम लोग डिस्कस करेंगे, मैं ऐसे ऐसे चीजों को आज कवर करने वाला हूं जो कि आने वाले एग्जाम के लिए बहुत इंपॉर्टेंट है. सर्कुलर ऑर्बिट है ये. उसको कैसे लॉन्च करेंगे? लॉन्च कौन करेगा? इंडिया करेगा. द लॉन्च सर्विस, right? That ISRO will provide. And we are going to use GSLV. Which version? MK2 Mark II. है ना? तो ये सारे फैक्ट्स हैं जो आपको याद रखना होगा. These all facts you have to remember that. That launch surveys from Sriharikota, Mark II will be used for it. Nisar will go to the. Now, अब यहाँ पर डिपेंड करता है हाइट. What is the height of this orbit from the surface of the earth? कि what will be the height of this orbit? मैंने क्या बताया कि जब भी रिमोट सेंसिंग सैटेलाइट होता है, किस तरह का ऑर्बिट पे होता है? लो अर्थ ऑर्बिट, LEO, लियो. Used in which type of orbit? Low earth orbit. Low earth orbit. So we are going to place into 748 kilometer height circular sun synchronous polar orbit, that is a low Earth orbit. You can see here this one. This will be the part of it. Inclination जो है 707. I'll again show you there. This will be the part of it. The orbit will be circular. 747 kilometers. This height will be the height of the orbit. That is a 747 kilometers. That's the altitude. Polar orbit, circular orbit, sun synchronous orbit, and at the same time, it is inclined at 98 degree. 98.3 degree inclination is there. But the orbit is not exactly 90. It's not exactly 98 degree. It is inclined by 8 degree. तो यहाँ जो ये ऑर्बिट का जो इंक्लिनेशन है, ऑर्बिटल जो प्लेन होता है, ऑर्बिट के जो प्लेन है वो इंक्लाइंड है, इंक्लाइंड टू 98 डिग्री. एग्जैक्टली 90 डिग्री पे नहीं है, 8 डिग्री टिल्टेड है, टिल्ट है ना, 8 डिग्री टिल्ट किया हुआ है, वहां पर होगा. राइट, दैट्स व्हाट इज द all specification, right? And the spacecraft Nisar, both governments have built, India and America, NASA and ISRO together have built this spacecraft there, right? And this I've said here, it is going to carry what? Radar. This is radar, what I've drawn here. It's called SAR, synthetic aperture radar. I'll come to that. What is the objective radar? We'll see that. We are going to cover this one. So you know that you have to know certain facts, certain type of facts, you have to be totally aware of it. ठीक है, आप एक बार पढ़ो, अच्छे से पढ़ो, और सारा फैक्ट पता होना चाहिए, और फिर पता होना चाहिए मिशन का ऑब्जेक्टिव क्या है ना, उससे में क्या क्या काम होगा, क्या क्या चीजें हम, what all things we'll be learning about from the mission. That becomes another important area, right? From there, that becomes very important. So when you visualize, when you imagine, when you visualize, then you are able to understand what exactly the mission is all about, right? So I've used certain kind of facts here. So around 700 kilometers, the orbit will be there. Circular orbit. What is the meaning of circular orbit? From the surface of the Earth, it will always maintain the same distance, same height. That's what comes here. Now comes here. Now, if you look at this particular one, right? What work, right? Nisar will carry out. What is the mission objective, right? So I'll come to the mission objective. So if you take here Nisar mission, let me bring this Nisar mission objectives in a flow chart. What is Nisar mission? I have told you. Now let's look at here. First very important aspect, which I would like to add here, that is a first important thing is in terms of mapping Earth surface and interior. Even interior of the Earth, that will be studied, particularly the crust. Is going to study Earth's crust. Upper part of the Earth, है ना, वो part को study किया जाएगा. That means it will be here study of dynamic, I'm using the word here, dynamic aspect of Earth. So that is what comes here, geology. So when you say dynamic aspect of Earth, you have read in geography plate tectonics. You all know Wagner theory, plate tectonics, which cause earthquake. That is dynamic aspect. No? Our Earth crust is made of number of plates, and the movement of plates, and its subduction and the collision, that give rise to tremor or earthquake. So here, third thing will be here. Here, this one. Study of earthquake. So not only study of earthquake, what is very important? Event can help in prediction, forecast. Will help in prediction of changes, whatever changes, right? Changes within Earth. ये सैटेलाइट बहुत इंपॉर्टेंट है इंडिया के लिए. क्या क्या पृथ्वी के नीचे और पृथ्वी के ऊपर बदलाव हो रहा है, whatever changes are there, that the NISAR will measure. It will have 12 days cycle, morning till evening. So here help in prediction of changes within Earth and on surface. Now what is second thing here? Second thing is that it is going to study ecosystems. What are ecosystems? Such as forest, grassland, vegetation, right? Whatever changes are taking place. So it is also has an ecological, environmental aspect. That means, sir, it is also going to study and get the data, right? Here, study of changes of ecosystem. Whatever natural ecosystems are there, जो भी इसमें बदलाव हो रहा है, चेंजेस हो रहा है, उसको स्टडी किया जाएगा. Again, in this context, it will be studying of cryosphere. What is cryosphere? What do you mean by cryosphere? Cryo means very, very low temperature. You know that. So that is a poles, Arctic, Antarctica. And you know third pole. What is third pole? What is third pole? Glaciers. Melting of glaciers. Global warming, climate change. That's a mountain glaciers. And आपको सबको पता है कि अभी क्या हो रहा है ग्लोबल वार्मिंग के कारण the glaciers are melting very, very fast. Like, you know, Himalayan glaciers. अभी recently सिक्किम में लोनाक लेक. You know what Lonak Lake? Lonak Lake in Sikkim, which provides the Tista River water. So there was something called glacial lake outflow, GLOF. Why glacial lake outflow happened or lake outburst? One of the reasons is too much of water. And from where the too much of water such lakes get? Melting of glaciers. जब ग्लेशियर का पिघलना होता है ना, मैं हिंदी में भी समझा देता हूं. जब ग्लेशियर का पिघलना होता है तो पानी का स्तर ज्यादा होगा. तो क्या होता है कि ऐसे जो लेक होते हैं जिनकी दीवार बनी होती है मोरेन से. व्हाट इज मोरेन? ग्लेशियल डिपॉजिट. तो वो क्या हो जाता है, होल्ड नहीं कर पाता है, इट्स नॉट एबल टू होल्ड एंड देन ब्रेक्स. तो व्हाट विल हैपन, द एंटायर वाटर विल कम डाउन फ्रॉम दिस. ऑल लेक्स आर अपहिल, ऊपर होता है. द वाटर कम्स डाउन causing the flood, flash flood, है ना. वो सब सिक्किम में भी हुआ था, लोनाक लेक का हुआ था. हिंदू पेपर हैज कवर्ड देयर. इज ऑल क्लाइमेट चेंज इंपैक्ट, राइट. एक और चीज मैं बताता हूं, क्लाउड बर्स्ट, heavy downpour, heavy rainfall within few seconds. All this will be studied through NISAR. So it's going to our environment kind of here. So here study of cryosphere, glaciers. So that is what called here impact here. Study of impacts of climate change. क्या क्या है? Like for example, you know wildfire. What is wildfire? That you all know that wildfire is what? The forest fire, extreme temperature, where the forest get caught with fire, forest fire. California forest fire, Australia bush fire, Nainital forest fire. All these are there. ये सब कुछ है जो फॉरेस्ट फायर वगैरह होता है ना वहां पे सर. देन आई मेंशन हियर क्या मैंने भी क्या बताया यहाँ पर, दिस क्लाउड बर्स्ट. All these are natural calamities, right? Right. And again, you know, cloud burst can result into flood, landslide, ये सारा है. Melting of glaciers वगैरह जो है, right? That will be studied there. ठीक है. तो ये दो चीज है. तीसरा जो है थर्ड, आई एम गोइंग टू थर्ड वेरी इंपॉर्टेंट वन. तीसरा जो थर्ड जो है, थर्ड वन वेरी इंपॉर्टेंट. आई राइट इट बिलो देयर. सब लोग लिख पा रहे हैं अभी? क्योंकि मेरे पास इतना ही स्पेस है, इसीलिए मुझे सब कुछ लिखना होता है. आई एम लुकिंग एट योर चैट बॉक्स नाउ. Yes, groundwater also there. Very true. Somebody has given groundwater. Bhanu has given the groundwater. Yes. Groundwater measurement will also be done through part of it. Okay. So I think everybody is on the page. They're able to see that. I've just looked into chat box there. है ना? तो अब इसी का continuation जो है, that's the continuation part. Let me do the continuation part. Another thing what comes here, that is a study of water cycle. Study of water cycle, you know, hydrological cycle. And now this hydrological cycle that is being disturbed. You know, this cycle has got disturbed. What is water cycle you study? Evaporation, condensation, cloud formation, precipitation, rainfall, and all these are getting affected because of global warming. ग्लोबल वार्मिंग के कारण इस पे पूरा वाटर साइकिल को प्रभाव पड़ रहा है ना. वहां पर जो उसको स्टडी किया जाएगा. और ये किससे लिंक्ड है? द स्टडी ऑफ किससे लिंक्ड है? ये स्टडी ऑफ फ्लड्स एंड ड्रॉट. और ये किससे और लिंक्ड है? एग्रीकल्चर. निसार विल ऑल्सो स्टडी एग्रीकल्चर इम्पैक्ट. Crop yield, crop impacts on agriculture because of the changes in water cycle, due to changes. And what is causing the changes? Global warming, changes in water cycle, hydrological cycle. Groundwater भी इसी में आएगा, रिचार्ज एंड एवरीथिंग, है ना, उसको पता लगाया जाएगा. एंड अगेन फाइनली disaster management. It will also study disaster management, earthquake, landslide. All these are part of the disaster management, right? Help in disaster management. जो भी ऐसे disaster management है, वहां पर निसार के डाटा जो है काम आएगा. Will help in disaster management. Is S. आपदा प्रबंधन में ये हमें मदद देगा, ये जो मिशन जो है. तो कई इसके ऑब्जेक्टिव्स हैं, मतलब एक नहीं कई ऑब्जेक्टिव्स हैं. तो पहला क्या जानना है? निसार क्या है? निसार इज द इंडिया एंड अमेरिका जॉइंट मिशन. ठीक है. और अभी मैंने क्या बताया कि जो इसमें जो पोलैरिमीटर है, एल बैंड, नासा इज गिविंग and S band, S strategic or satellite band that ISRO is providing. It carries a radar, synthetic aperture radar, on the top of the satellite. 747 kilometers circular sun synchronous polar orbit, 98-degree inclination. It will be launched by GSLV Mark 2. ये सब जितने भी डाटा है सारा फैक्ट है, और फिर आता है यहाँ पर ऑब्जेक्टिव, ये पता होना चाहिए और मस्ट बी अवेयर ऑफ दैट. तो लेट्स से सपोज करो कि इस बार आने वाले एग्जाम में क्वेश्चन आ जाए, प्रीलिम्स एग्जाम May 26th, and there is a question on Nisar. So this all thing you have to be aware of it. It will be interconnected and will be asked in the exam, है ना? ऐसा क्वेश्चन वहां पे पूछा जाएगा. तो ये बहुत इंपॉर्टेंट एस्पेक्ट में आपको ध्यान रखना है. मैं इसलिए बता रहा हूँ, जो मैं पढ़ा रहा हूँ, आई एम टारगेटिंग योर अपकमिंग प्रीलिम्स एग्जाम, सो दैट इफ एनी क्वेश्चन कम्स, जो लोग आप में से ये इस बार का पेपर देंगे एग्जाम, दोज ऑफ गोइंग टू अपीयर इन द एग्जाम, you are prepared with this kind of topics from science and technology, right? So it's the multiple dimensions of Nisar, right? Multiple dimensions of this Nisar. और मैंने क्या बताया कि जब भी आप कोई भी चीज पढ़ते हो, whenever you are studying, what you need to do is you need to go to the website. You need to go to the website, right? So now before I go to the website here, now let's look at here. This is what I mentioned here. This is what we have seen, the image. Okay? And I have said L band and S band. So now if you look at here, see here, the inclination. Now one more fact is that payload, 3,100 kilogram. GSLV MK2 can go up to 3 tons. PL is a payload. How much is the payload? This one. 3 ton. 3 ton. That is the payload here. And you can see here this one. Quick fact here. Scientific objective. Even now you can see here what is given here. Response of ice sheets there. Glaciers and all this. Climate change. Interaction of sea ice and climate. Then you can see dynamics of carbon storage. You know that you have read in environment. Environment आपने पढ़ा होगा. Trees and plants carry out photosynthesis. So that is in terms of what is something called photosynthesis. So when the forest, tree, plants, they carry photosynthesis, so they will take CO2 gas. CO2 को use किया जाएगा. अब यहाँ है ना wooded, agriculture, wetland, another thing see, wetlands. Then you can see permafrost, Siberia, where soil is frozen with ice. Wooded का मतलब होता है forest. Wooded means forest. Forest system. Then again you see likelihood. That is a possibility, probability, forecast, prediction of what? Earthquake. Again you can see volcanic eruption. Interior of the earth, ना lava flow, जो क्रेटर वगैरह होते हैं वोल्केनो का, अगर हम अंदर से पता कर सकते हैं तो हमें पता चल सकता है कि वोल्केनो कब एक्टिव होने वाला है, लावा का फ्लो होने वाला है, और फिर ये लैंडस्लाइड्स वगैरह जो है अर्थक्वेक के बारे में. तो मैं भी क्या बता रहा हूँ, मल्टीपल ऑब्जेक्टिव्स है. एक ऑब्जेक्टिव नहीं, कई सारे ऑब्जेक्टिव्स है. इट हैज गॉट सो मेनी ऑब्जेक्टिव्स. निसार हैज गॉट सो मेनी ऑब्जेक्टिव्स देयर, right? So this becomes very important. So now when you say carbon storage, so what comes here? Very important one. Again from environmental ecology, carbon cycle is a part of carbon cycle, just like water cycle. There's a carbon cycle. Yeah, how much photosynthesis CO2 gas taken by plants, algae, all this kind of organism, and converted to glucose, carbohydrate. है ना, उस पे भी काम करेगा. मुझे उम्मीद है कि आप समझ पा रहे हो. Those who are there, you are able to understand here, right? Early warning system, yes, post disaster mapping, all these are there. Synthetic aperture radar is a radar. Sejal Soni is asking that. That is what she is asking there, and I'll come to that radar also there. But this part is okay there. You all are able to see here. Okay, let me go back here. What she is asking here, synthetic aperture radar. This one, synthetic aperture. See, जब भी aperture होता है, that is in terms of its opening to the wavelength, right? It's basically when you come across here, that is here aperture. जब aperture की बात आती है, aperture size, radar का जो size होता है, that determines frequency of इलेक्ट्रोमैग्नेटिक जो होते हैं, इलेक्ट्रोमैग्नेटिक वेव जो होते हैं, जो सिग्नल होते हैं, उसको वहां पर जो है उसका फ्रीक्वेंसी के तौर पे होता है. विजिबल लाइट, एक्स रे, यूवी रेज, गामा रेज, किस पे डिपेंड करता है ये साइज? अपर्चर का साइज डिपेंड करता है कि उसका कितना फ्रीक्वेंसी या वेवलेंथ होगा उस वेव का. अब यहां पर क्या होता है, दो इंस्ट्रूमेंट है, यू हैव टू इंस्ट्रूमेंट्स हियर. राइट, ये दो इंस्ट्रूमेंट्स हैं. एक है एल बैंड बोलते हैं, एल बैंड पोलारीमीटर. पोलारीमीटर इज इंस्ट्रूमेंट. आई शो यू द पोलारीमीटर कि कैसा होता है. नाउ दिस इज बीइंग प्रोवाइडेड बाय नासा. नासा इज गिविंग दिस पोलारीमीटर. एंड दूसरा जो होता है एस बैंड, मतलब ये फ्रीक्वेंसी है. व्हेन यू से बैंड, बैंड इज द रेंज ऑफ फ्रीक्वेंसी. सिग्नल जो है ना, सिग्नल विल बी रिसीव्ड, है ना, रिसीव्ड एंड ट्रांसमिटेड बैक. तो यहां पर एक इंस्ट्रूमेंट होगा, पोलारीमीटर होगा, ये चीज है. पोलारीमीटर को तो पोलराइजेशन बोलते हैं, लाइट के अकॉर्डिंग वो काम करता है. दिस इज बाय द ISRO. इसरो इज गोइंग टू प्रोवाइड दिस सर्विस. तो कहने का मतलब ये है कि ये अगर अर्थ है, दिस इज अर्थ, राइट, एंड दिस इज द सैटेलाइट. This is satellite Nisar. So what will happen? The signal which will be passed, है ना, ये जो सिग्नल जो पास होगा यहाँ से, that signal which will be given and the signal which will be received, that will be done through this polarimeter. ये इंस्ट्रूमेंट का काम होगा यहाँ पर. एल बैंड जो होता है 1 गीगाहर्ट्ज से, ये जो एल बैंड है, एल बैंड है ना, इसका आता है 1 गीगाहर्ट्ज. 1 गीगाहर्ट्ज से 2 गीगाहर्ट्ज तक फ्रीक्वेंसी होती है. अल्ट्रा हाई फ्रीक्वेंसी होता है. उसमें रेडिएशन जाएगा. ये जो रेडिएशन जो जा रहा है और ये रेडिएशन जो आ रहा है, जाना और आना जो है, वो डिपेंड करेगा फ्रीक्वेंसी पे. राइट, एस बैंड का भी वैसे वहां पर है, 2 to 4 गीगाहर्ट्ज वहां पर होता है. एंड यू कैन सी पोलारीमीटर. पोलारीमीटर में इंस्ट्रूमेंट दिखाता हूँ. पोलारीमीटर, यू विल फाइंड दिस इंस्ट्रूमेंट हियर. Polarimeter, this is a scientific instrument which is used. See, you don't have to become engineer, but you should know the name of this instrument. ये होता है. जहां से फ्रीक्वेंसी का सारा कुछ होता है, ये पोलारीमीटर बोलता है. Then you can see here polarimeter. पोलराइजेशन करता है. क्या करता है? पोलराइजेशन. There is a concept in physics called polarization. It work on this part of it. So it has a instrument part of it there. Right, रोटेशन वगैरह होता है, सारे जो एक्टिव चीज होता है उसको, that part you come across. If you take an image, this is one. Right, and what is here? Let's say synthetic. If I write here synthetic, or let me write it like something. I write like this one. L band. I'm writing this L band polarimeter. See, जब भी कोई भी चीज आप पढ़ते हो, then you must go and then try to find out there. दिस इज व्हाट यू हैव। ये इंस्ट्रूमेंट है, ये इमेजिंग में काम आता है। ये कहाँ कैरी होगा? निसार में होगा। निसार विल कैरी दिस इंस्ट्रूमेंट, है ना, जिससे वो सारा डाटा और डाटा इमेजिंग वो सारा कुछ यहाँ पे किया जाएगा। दिस व्हाट द इंस्ट्रूमेंट लुक्स लाइक हियर। यहाँ पे ऐसा होता है इंस्ट्रूमेंट का, यू हैव दिस काइंड ऑफ इंस्ट्रूमेंट देयर। तो वैसे एस बैंड का होता है ना, एस बैंड विल हैव द सेम काइंड ऑफ थिंग हियर, व्हाट आई मेंशन हियर। So it will receive the signal and send back the signal. ठीक है, ये क्लियर है यहाँ पर। तो ये चीज जो मैंने भी बताया यहाँ पर, दिस व्हाट आई मेंशन हियर, ठीक है। एंड यू कैन सी हियर दिस वन, कैन यू सी हियर एल बैंड कितना वेवलेंथ कर सकते? 24 सेंटीमीटर पोलैरिमीटर नासा। एस बैंड 12 सेंटीमीटर वेवलेंथ पोलैरिमीटर। कौन कर रहा है? इसरो। अब वो वेवलेंथ का साइज, अब वो उसका उतना मैटर नहीं करता है। आपको केवल ये ध्यान रखना है कि एल बैंड जो ये इंस्ट्रूमेंट है वो नासा बना के दे रहा है, और एस बैंड जो सैटेलाइट निसार में होगा वो इसरो बना के दे रहा है। ये दो एजेंसी का वहां पर काम हुआ पर है। और इससे क्या यूज होगा? जो भी सिग्नल रिसीव और सेंड बैक हो रहा है, जितने भी सिग्नल होंगे, जो भी ये इमेजिंग करेगा, मैपिंग करेगा, सारी जानकारी वहां से आएगा। एवरीथिंग विल कम फ्रॉम देयर, ठीक है। दैट इज व्हाट यू हैव टू कीप इन माइंड, राइट। तो ये चीज को ध्यान में रखना है आपको। दिस इज व्हाट यू हैव टू कीप इन माइंड, right? So this is what I have explained here. Earlier it was planned for 2021, but now it has been delayed here, है ना। उसको हमने डिले कर दिया है यहाँ पर जो है। पहले प्लान था लेकिन अब इसको डिले किया हमने, क्योंकि बीच में कोविड आ गया था, नहीं तो ये 21 में ये लॉन्च हो जाता। बट बिकॉज ऑफ द पैंडेमिक, कोविड के टाइम में इसको हमने डिले किया है। और अब देखो क्या है, ये जो मैं आपको दिखा रहा हूँ यहाँ पर। अब आप जब आप जाएंगे यहाँ पर, है ना, अब जैसे यहाँ पर मैं निसार के बारे में, अभी डेट जो है निसार लॉन्च, ये अभी हिंदू पेपर में आया हुआ है ये चीज है। 30 मार्च 2024। एग्जाम कब होगा? एग्जाम इज इन द मई, 26 मई। क्या पता, देयर माइट बी वन क्वेश्चन दिस ईयर एग्जाम, है ना। तो जीएसएलवी एंड कैन यू सी जीएसएलवी MK2 मार्क 2 30 मार्च, ठीक है। तो इसका पूरा डिजाइन वगैरह सब हो चुका है। तो ये सारा जो है, राइट, वो ट्रैक किया जाएगा वहां से। एंड यू कैन सी हियर दिस वन व्हाट आई एम नाउ प्लेइंग हियर।
With NISAR, we're tracking the changes of the solid Earth and how it's moving, ecosystems, ice cover, and any other thing that's changing at the scale of a centimeter on the Earth in a way that we've never been able to see before. Because of these very subtle motions we can measure, we're able to understand what's happening below the surface of the Earth at great precision. We can see subsidence that allows us then to manage resources of what's happening below the Earth.
Scientists want to study the movements of the Earth's surface to understand the processes that could trigger earthquakes, volcanoes, and landslides.
And that allows us then to understand risks associated with natural hazards,
which in turn can help in mitigation measures and early response.
इससे क्या होगा? हम प्रॉपर डिजास्टर
The
मैनेजमेंट कर
surface
पाएंगे।
include melting of glaciers and ice sheets, changes in forest biomass, soil moisture, and shoreline changes.
It's based on radar. So it has two different frequency radars, and it
दो radar
basically
जो होता है,
looks through clouds and
frequency
sees the
वहाँ पर।
surface of the Earth. What you're seeing is an animation of how the radar collects data, and you can see these beams coming down from
अब
the
देखो
antenna and
कैसे-
coming back, and on
कैसे-
the ground you can see
क्या
the
ये
smoke.
update कर रहे
That's
हो?
where it collects the data, and when it combines them all together, you get what we
मैं
need
आपको फिर से
for
दिखा रहा हूँ,
science.
तो ध्यान से देखो आप।
Data, you can see these
ये आपको टॉर्च लाइट के जैसा फ्लैश दिख रहा है, जो टॉर्च लाइट की तरह ऊपर नीचे जा रहा है,
beams coming down from the
दिख रहा है
antenna
ये?
and coming back, and on the ground, you
ये
can
जो
see
दिख रहा है
the
आपको?
swath. That's where it collects the data.
जो
and
लाइट
when
की
it
तरफ
combines them
bounce
all
back
together, you get what we need
सिग्नल है
for
वो.
the science.
We can see day and night through clouds,
ये
and
देखो
we're
आप.
covering all of the
Circular
land,
orbit है.
and all of the ice-covered surfaces of
पूरा
Earth
अर्थ को कवर करेगा.
every week. NISAR is quite unique in that it has two radars, one provided by NASA, one provided by ISRO, the Indian
एक
Space
नासा के
Research
द्वारा है, दूसरा इसरो
Organization.
द्वारा है.
NASA and ISRO have collaborated in this mission. Till last year, we were there at JPL, NASA, where the radars got integrated and tested and were shipped back from Sriharikota, which is a ISRO launch pad, and it is going to be launched by
कौन सा rocket है?
GSLV Mark II.
GSLV
So
M-K2.
we are just looking forward for the launch of NISAR in the forthcoming year.
NISAR is measuring the changes on the Earth's surface, which are either
Changes on the
factors
Earth's
or
surface.
indicators of climate change. The society
Climate change.
will also immensely benefit due to its contribution towards disaster management,
Disaster
providing
management.
food and water security.
Food
These
chain.
things are global problems that the global community needs to come together to resolve.
Now it looks like we are no more belonging to two different worlds and we all belong to the space community. That's it.
There's the excitement about what we are going to learn that we didn't even anticipate we're going to learn.
Thousands of scientists will work in this project. हजारों वैज्ञानिक इसमें सारे डाटा को यूज करेंगे. नासा का JPL जो है उसका मैंने अभी आपको दिखाया, जहां पर ये चीज वहां पर है. हजारों वैज्ञानिकों जो है इसके डाटा को यूज करेंगे. अगर किसी विद्यार्थी ने, किसी स्टूडेंट ने इस बात को अच्छे से समझ लिया, अगर ये चीज को अच्छे से समझ लिया, तो मुझे नहीं लगता कि कोई भी तरह क्वेश्चन नहीं सॉल्व होगा. यू विल बी एबल टू सॉल्व द क्वेश्चन अगर आपको अच्छे से समझ में आ जाए. इसलिए कहता हूँ यू आर रीडिंग अ लॉट ऑफ थिंग्स देयर, बट अंडरस्टैंडिंग बिकम्स वेरी वेरी इंपॉर्टेंट. ऑलराइट, आई विल डू वन थिंग हियर. लेट मी डू वन थिंग हियर. शिव शंकर, अब अनम्यूट कीजिए. शिव शंकर.
गुड आफ्टरनून सर.
गुड आफ्टरनून. मुझे बिना देखे आप बताओ क्या क्या आपको निसार के बारे में समझ में आया.
सर निसार
आपका हिंदी मीडियम है, इंग्लिश मीडियम है?
सर इंग्लिश मीडियम है, लेकिन इंग्लिश तो आई एम नॉट एबल टू स्पीक सो मच फ्लुएंटली.
चलो कोई बात नहीं, आप बाइलिंगुअल करके बता दो, इंग्लिश हिंदी मिक्स करके बता सकते हो.
ये एक सन सिंक्रोनस पोलर ऑर्बिट में मूव करता है. सर्कुलर ऑर्बिट में ये इसरो और नासा का कोलैबोरेटिव मिशन है ये.
बिल्कुल सही है. ठीक है.
लोअर अर्थ ऑर्बिट में ये मूव करेगा.
ठीक है. कितने किलोमीटर की ऑर्बिट होगी?
यस यस सर.
कितना हाइट होगा ऑर्बिट का?
747 किलोमीटर.
गुड, वेरी गुड, वेरी गुड.
इसका ऑब्जेक्टिव है ईयरली वार्निंग सिस्टम को ये स्ट्रॉन्ग करेगा, डिजास्टर मैनेजमेंट में हेल्प करेगा, एंड
अभी आपने वीडियो भी देखा, उस वीडियो में भी कई बातें बताई गई है.
सर डिजास्टर मैनेजमेंट, कुछ अर्थ के इनर पार्ट में जो मूवमेंट हो रहा है, जैसे वोल्केनिक इरप्शन.
गुड, वेरी गुड. नहीं, आप सही बता रहे हो. अर्थक्वेक, प्लेट टेक्टोनिक मूवमेंट है, लैंडस्लाइड वगैरह जो होता है वो चीज है. फिर यहाँ पे क्या है, मेल्टिंग ऑफ आइस है ना, दैट चेंजेस विल बी मॉनिटर. व्हाटएवर चेंजेस गिविंग कार्बन कैप्चर. क्या होता है कार्बन कैप्चर? इकोलॉजी में आप पढ़ते हो, देयर इज अ कॉन्सेप्ट कॉल्ड एज अ प्राइमरी प्रोडक्टिविटी, इकोसिस्टम प्रोडक्टिविटी. दैट इज द फॉर्मेशन ऑफ बायोमास एंड दैट कम्स फ्रॉम द कन्वर्जन ऑफ सनलाइट एंड कार्बन डाइऑक्साइड इनटू कार्बोहाइड्रेट. तो वो चीज भी मेजर किया जाएगा कि अर्थ में कितना कार्बन स्टोर हो रहा है, कितना बायोमास बन रहा है, हाउ मच बायोमास बीइंग मेड, दैट विल बी डन देयर. ठीक है. डिजास्टर मैनेजमेंट विल बी द पार्ट ऑफ इट. अगेन और क्या इसमें ऑब्जेक्टिव है इसके अलावा? वाटर साइकिल, ऑल थिंग्स आर देयर, है ना. तो ये चीज है. ओके, somebody else, how many radar will be there? How many radar is going to be used there? I've used the two word polarimeter. कितने हैं वहां पर? Two are there. One is L band, another is a yes
band.
L band होगा, दूसरा होगा S band. L band, S band. Who is given L band?
L-band SR
NASA.
NASA and S-band ISRO.
इसरो।
Yes.
और हम कहाँ से लॉन्च करेंगे इसको? सतीश धवन स्पेस सेंटर
श्रीहरिकोटा।
श्रीहरिकोटा। कब लॉन्च होने वाला है? अभी जो
30 मार्च को सर।
30th March this year, next month, ठीक है। एंड विच रॉकेट वी आर गोइंग टू यूज लॉन्च व्हीकल? कौन सा रॉकेट हम यूज करेंगे लॉन्च के लिए निसार को? GSLV? GSLV?
Your
Mark
voice
2.
lagging, sir.
I am asking that which rocket we are going to use for this?
Yes, sir. GSLV Mark 2.
Mark 2. Right? These are things, बस हो गया। अब आपको पढ़ने की जरूरत ही नहीं है। अगर आपने ये चीज को दिमाग में रख लिया, आपको याद रखना है बस, दैट्स इट। L बैंड S बैंड दो है वहां पर, फिर आपको टेंशन की बात करें, राइट? तो नाउ दैट इज व्हाट आई हैव मेंशन हियर। अब मैं नेक्स्ट मिशन पे आता हूं, चंद्रयान मिशन। चंद्रयान एंड मंगलयान मिशन, आई एम गोइंग फॉर दैट लूनर मिशन। ठीक है, वी विल बी लर्निंग अबाउट लूनर मिशन। आई एम नाउ कमिंग टू द लूनर मिशन ऑफ इंडिया। So let us go into Chandrayaan and Mangalyaan mission. Then I'll be coming to Astrosat. हम लोग डिस्कस करेंगे Astrosat, Exposat, है ना, वो सारे हम लोग डिस्कस करेंगे। And also I'm going to discuss astronomical observatories के पार्ट में। So we are going to cover a lot of new topic of today's class, है ना, वो सारा हम लोग डिस्कस करने वाले हैं। So let us go to the first part, Chandrayaan 1. Chandrayaan 1. So let me write something here. पहले कुछ बातों में लिख के बताता हूँ, and then I'll go to the something supportive. I'll do that, but let me write here, है ना। पहले कुछ चीज को मैं समझा देता हूँ, उसके बाद हम लोग बाकी चीजों को करेंगे। All right, so if you look at ISRO's lunar mission, right? So we started with the Chandrayaan, है ना, Chandrayaan 1. So let us go to some basic thing here. Let me cover this Chandrayaan 1 basic thing. First thing is that it was launched in 2008 by using PSLV C11. We used the PSLV C11. It was extra large version, XL version, XL configuration that was there, extra large, है ना। ये भारत का पहला PSLV का एक्स्ट्रा लार्ज वर्जन था। अक्टूबर लॉन्च हुआ था, फिर हमने उसको मून तक पहुंचाया वहां पर, ठीक है, 2008 में वहां पर मिशन था। दूसरा पॉइंट क्या है? ओनली ऑर्बिटर, it was placed 100 kilometer orbit of moon. मून के 100 किलोमीटर के ऑर्बिट पे इसको रखा गया। That means this is the moon. So the orbit was this one. 100 kilometers. 100 kilometers there. So Chandrayaan 1 was simply an orbiter. It was simply an orbiter. 100 किलोमीटर की ऊंचाई पे, है ना, उसका जो डिस्टेंस था, that was a part of it. And there were 11 instruments on board, है ना, इसमें 11 instruments थे। Although Chandrayaan 1 mission didn't last entire lifetime of the mission. The entire lifetime of the mission, what we planned, it was not able to be there. After 6 to 8 months, we have to end our mission. उसको end करना पड़ा। तो इसमें जो 11 instruments है, these are the 11 instruments. These are PSLV C11, what we use here. These were the instruments. इसमें सबको याद नहीं करना है, सारे इंस्ट्रूमेंट का नाम याद नहीं करना है, right? इसमें सबसे important है, the most important was this one, moon impact probe. Moon impact probe. What you see right here, see, it's just like a cap. It was just kept on the top of the satellite, and this was dropped. This was dropped to moon surface. इसको मून के सरफेस पे ड्रॉप किया गया था. So when the MIP was getting down, descent, it has found water. जब MIP नीचे की ओर गिर रहा था, उसको क्रैश लैंड किया गया था. जब ये नीचे की ओर जा रहा था, तो इसके इंस्ट्रूमेंट ने वाटर को डिटेक्ट किया, लॉस ऑफ वाटर फ्रॉम सरफेस ऑफ द मून, राइट? It detected the loss of water from the surface of the moon. Detected loss of water. Which again needed to be confirmed. है ना? It was just like a hat. है ना? जैसे टोपी हो तो टोपी की तरह ऊपर था. That needed to be confirmed. But the thing was that one of the achievements, you can say, one of the achievements of Chandrayaan-1 mission was that this MIP, Moon Impact Probe, was able to detect loss of water from the surface of the moon. मून के सरफेस से लॉस का वहां पर था. करेक्ट. दूसरा इंस्ट्रूमेंट ये तो रेडॉम था. ये सारा याद नहीं कर, रेडिएशन डोज मॉनिटर. देन यू कैन सी थर्ड वन, सर 2, इंफ्रारेड स्पेक्ट्रोमीटर. देन LLRE, lunar laser imaging ranging instrument. Then comes this one, terrain mapping camera, TMC. Then you can see one XX Chandrayaan-1 X-ray spectrometer. Then another very important one, M3. One important is this one, MIP, Moon Impact Probe. Another instrument was this one, M3, Moon Mineralogy Mapper, minerals. You know, moon contains precious minerals. Moon contains precious minerals, right? Who knows, after 50, 60 years, there could be mining on the moon. Man will do mining on the moon, bring those kind of mineral back to the earth. The mineral mapping. Then you have this one, 8th one, mini SAR. Right, again you can see here. Can you see very important one? Synthetic aperture radar. Can you see here? SAR. NISAR is there, NASA ISRO synthetic. So you have a mini synthetic aperture radar. Then very, very important one, this one. A very important instrument, HYSE, hyperspectral imager. सरफेस मैपिंग, सरफेस इमेजिंग, राइट? तो यहाँ पे ये दूसरा बहुत इंपॉर्टेंट इंस्ट्रूमेंट था, HYSE, मल्टी वेवलेंथ इमेजिंग, है ना? अलग अलग वेवलेंथ पे इमेज किया जा सकता है. देन हाई एनर्जी एक्सरे स्पेक्ट्रोमीटर, ये 10वां था. एंड देन यू कैन सी हियर 11, चंद्रयान एनर्जेटिक न्यूट्रल एनालाइजर, देन फॉर एटमॉस्फेयर. एंड 12 था, 12 swim, solar. See here another thing, solar wind monitor. You know, coronal mass ejection, right? And I'll tell you very important, Chandrayaan-2 also carries same kind of instruments. Chandrayaan-2 में भी similar type के instruments हैं जो कि even solar wind को भी measure करते हैं. जब solar flare आता है from the sun, what Aditya is doing, है ना, जो आदित्य कर रहा है, the solar wind है वो उसका moon पे, when it comes to the moon, again this swim can find out. So this is another very important instrument. And one more, what is very important one here, this one, TMC, terrain mapping camera, mapping the surface of the of moon there. So if you look at out of 12 instruments, the important ones were MIP, TMC, M3, then coming HYSE, and then swim. Right? ये जो 5 इंस्ट्रूमेंट्स हैं, ये बहुत इंपॉर्टेंट इंस्ट्रूमेंट्स था. एंड वाज जस्ट लाइक ऑर्बिटर. ये पूरा का पूरा ऑर्बिटर था. ये पूरा का पूरा ऑर्बिटर मिशन था. राइट? एंड 100% ये याद रखना है, ये पुराना हो चुका है. इट्स ऑलरेडी मोर देन 10 years ओल्ड मिशन प्रोग्राम, बट इट हैज अ रेलेवेंस. कई बार जो कैरी ऑन होता है, चंद्रयान 2, चंद्रयान 3, दैट इज बेस्ड ऑन द अर्लियर मिशन, फर्स्ट मिशन. पहला मिशन यही था हमारा, on the surface of studying the moon there, that we have done there. And what is this one? ये solar panel है. And you can see here there was single panel, not the double panel. Single panel को use किया गया था. Right? Again, remember that these are all things which India have been carrying out. Right? That has made India's position very high in the field of space science and astronomy. Right? Moon का जो वहां पर है, तो our orbital mission is very very important. तो पहला हमने ऑर्बिटर किया, चंद्रयान 1 मिशन. ठीक है. नेक्स्ट वी वेंट फॉर चंद्रयान 2 फॉर लैंडर रोवर, विक्रम लैंडर एंड प्रज्ञा रोवर, बट वी फेल्ड इन द लैंडिंग पार्ट. But then we did the Chandrayaan 3. There we successfully landed on south pole of the moon. और अभी रिसेंटली न्यूज में भी था ना, प्राइम मिनिस्टर नरेंद्र मोदी जी, he has given the name, जिस जगह पे विक्रम लैंडर ने टच किया, चंद्रयान 3. You know the name of the point? शिव शक्ति. राइट? और जहां चंद्रयान 2 फेल कर गया था, चंद्रयान 2 विक्रम लैंडर क्रैश लैंडेड. इट वाज नॉट एबल टू लैंड सॉफ्ट लैंडिंग नहीं हो पाया था. उसका नाम हमने क्या रखा है? तिरंगा. What's the name of the point has been given? Tiranga. And then Chandrayaan 3, where we successfully landed, we have given the name there. It was all in the news there. It was all based on the news, what was given there, right? South pole of the moon. But Chandrayaan 1 was simply orbiter. It was just like a satellite, went around the moon. So moon impact probe, what is very very important, moon surface and loss of water. That was very very important. है ना? पानी का प्रेजेंस होना मून में एक बहुत बड़ी खोज हो सकती है, और इसको बाद में उसको स्टडी किया जा रहा है. ये भी माना जा रहा है कि जो चंद्रमा के साउथ पोल है, वहां क्रेटर है और वहां पर आइस हो सकता है. आइस, प्रेजेंस ऑफ आइस कुड बी देयर. एंड पानी मिल जाना, जल मिल जाना, पानी मिल जाना, ये सपोर्ट कर सकता है कि भविष्य में वहां इंसान जाके रह सकता है. मैन कैन लिव ऑन द मून. ये सारी चीजों को स्टडी किया गया वहां पर जो है. तो ऑल्दो इट इज ओल्ड, ये मिशन पुराना हो चुका है. इट इज ऑलरेडी द ओल्ड मिशन देयर, बट सम ऑफ द थिंग यू हैव टू बी अवेयर ऑफ इट. So now let me go to this one. So if you take here this one, the what were the objectives here? The objectives of this, let me first bring the objectives here. First was here mapping of moon surface, imaging के लिए जो है moon surface. The moon surface was mapped. Second was here, that is a study of minerals found in lunar soil. मून के जो सॉइल है उसमें मिनरल्स का पता करना. तीसरा जो बहुत इंपॉर्टेंट जो था, दैट इज टू स्टडी और टू डिटेक्ट प्रेजेंस ऑफ वाटर. This was the 3 main objective. Then again, fourth one was gases in the atmosphere, to study gases in exoatmosphere of moon. मून का जो बाहरी वायुमंडल है ना, मून के बाहरी वायुमंडल में क्या क्या गैसेस प्रेजेंट है, That has been also studied by Chandrayaan-1 mission. Right? Chandrayaan-1 mission helped in that one. So that is another very, very important part. But although we were not able to be controversy there. So what is the achievement here? This one, which I mentioned here. The achievement, if you look at, that is a detection of loss of water from moon surface. By which instrument? I have already mentioned here, MIP, Moon Impact Probe. That's the achievement of that. Although it didn't last for a long time, you know? It didn't last for a long time, but it was able to find out. Right? This instrument was able to detect. ये चीज है. Right? So just keep this point in mind. From exam point, it becomes very important. मैं थोड़ा chat box देख लेता हूँ. आपके chat box में देखता हूँ. Yes, Shiv Shakti was there. Yes, orbiter only mission there. Now the question is that Shubham Raj, how this MIP was dropped. MIP was just eject. Eject. You can eject it. The electronic system, where you can have such kind of a machine, where you can, like, the moment the button is there, click, eject, just eject out, and then fall. Then fall to because the moon's gravity will attract. It was ejection was done, ejected. Today satellite technology is very, very advanced. Satellite technology बहुत advanced हो चुका है. सारा कुछ control होता है ground station से. Everything is controlled from there and part of there, right? So that is what comes into that. ठीक है? Now I'll be coming to Chandrayaan-2 mission. Let's go to Chandrayaan-2 mission. So this I mentioned about Chandrayaan-1. ठीक है? Chandrayaan-2 mission, if you look at this is Chandrayaan-2. So initially journey to the moon, Chandrayaan-2, which 384,000. So we were trying to land, but we were not successful, right? Initially we planned for this. NASA, remember that. NASA used this technology. NASA has carried out many missions to Mars, right? Mars missions mein, and their rover, rover and everything. Now we were negotiating with Russia about this technology. We were negotiating with Russia, but something didn't work. So we were not able to get this technology. So we tried different method. ठीक है? अब क्वेश्चन पूछता हूं मैं. I will just ask a question somebody here. So tell me, this system, what do you see that? US and Russia, remember that. USA and Russia, they use this technology. US and Russia, they use this technology. Right? Now tell me, what technology we used? Which technology we used? Did we use this technology? There's a parachute. For our Mangalyaan, for our Chandrayaan-2, did we use this technology? We didn't. No. India कोई और technology use किया. क्या use किया India ने? How India carried out? Initially it was planned. Initially planned like this. है ना? इसका प्लान था विद सपोर्ट फ्रॉम रशिया. इंडिया ने ये प्लान किया था कि हम रशिया से ये टेक्नोलॉजी लेके हम ऐसा लैंडिंग करेंगे. Easily planned like this, use the parachute with support of Russia. But again, we didn't go with Russia. Then India developed indigenous system. What we use, कौन बताएगा? ये चीज हम कर नहीं पाए. तो हमने कैसे Chandrayaan-2 का लैंडिंग का ट्राई किया, जो हम फेल हो गए. फिर चंद्रयान 3 हम लोग सक्सेसफुल हो गए. हाँ, who will tell me here? Let me ask the question here. Satyajit Nayak. Can you unmute yourself, Satyajit Nayak?
Good afternoon, sir.
You have not read Chandrayaan 2 or Chandrayaan 3?
I don't know.
Chandrayaan 2, Chandrayaan 3 you have not studied. I'm surprised.
Chandrayaan 3 somehow studied, but Chandrayaan 2 not.
नहीं, Chandrayaan 3 में कैसे किए थे? How we did in Chandrayaan 3?
Don't know, sir.
आप टीवी वगैरह नहीं देखते हो क्या? You don't see TV? It was all in the news. It's all in the news, TV, newspaper, everywhere. I'm really surprised you're not aware. Anyway, Pratiksha Upadhyay. Pratiksha? Pratiksha Upadhyay, can you unmute yourself? Many people, they hide behind the camera and then, whether, Pratiksha, are you there? And what happens there? They may be involved in some other work. They may not be attending the class. Anyway, I'll ask somebody else there. Rohit Singh. Can you unmute yourself, Rohit Singh? Okay, I'll ask somebody. Sai Charan, Kadapa. He's from Kadapa. Sai Charan. Sai Charan, can you unmute yourself? Yes, Sai.
Good afternoon, sir.
Good afternoon. How are you?
Fine, sir.
So you're from Kadapa, right?
Yes, sir.
The district is Kadapa, right? Where in
Sir,
Kadapa you stay? Your native place?
my native place is Kadapa itself, sir.
Acha, there only main city, only you stay there. Okay.
Near a small village.
There's small
Near
village.
Kadapa.
Right. Okay. No, I've been to those kind of places. That's what I've asked. So, now just tell how India tried with that. We didn't use the parachute system. How our Chandrayaan 2 and 3 missions were carried out? Landing part, soft landing. Yes.
Sir, I really don't know, sir.
How come? It was all in the news. You know the system there. Yes, who will tell me there? वो सारा news में था. Pankaj Singh will tell me. Pankaj Singh is nodding his head. So I'll ask Pankaj Singh there. Yes, Pankaj, you can unmute yourself.
Thanks.
Thank you.
Good afternoon, sir.
Good afternoon.
In Chandrayaan 3, ISRO used reverse thrust system.
Excellent.
In which when it's going in their gravitational force, which is 1/6 of the Earth system, then the reverse thrust is using for the relaxing the speed of the Chandrayaan.
Very good. Excellent, Pankaj. Very good. It was all in the news. These were all covered live. It was covered in the news. बहुत अच्छा. Well done.
Thank you, sir.
Well done. Good. We didn't use parachute system. It was simple thing. I'll share here. What he has said. See, when you are in the influence of gravity, let me just explain this one, because you have to know certain bit of technology. See, when you are reading science and technology, you must be aware of technology here. See, what was our this part? Our this, if I just draw the diagram here, this was our, and you know why it is very important? Republic Day parade. This on 75th Republic Day in this Kartavya Path, India Gate there. There was ISRO kind of a exhibition, and that Vikram lander with Pragya rover was there. Now this is the Vikram lander. This was the Vikram lander, and we did with the both Chandrayaan 2 and Chandrayaan 3, and it has this reverse. There was a thrusters were there. We use these thrusters. These are engine. These are the engine there. right? These are basically motor engine was there, right? So what we did was that this has a fuel. See, when let's say this is the moon, there is a moon here. The moon will always attract. Moon has a gravity, no? If anything comes under the influence of gravity, so what will happen there? With the help of the gravity, this gravity will be there. So any object will be falling there, right? As you know, Earth में भी ऐसा होता है ना, if you are in the atmosphere and you fall from the atmosphere, you will come down, you will fall down. So this will be falling very fast. This will be falling fast. Then fast falling will be there. So they use something called reverse thruster. What is reverse thruster? To reduce the speed. To control the speed of fall. This fall was there. So the speed by which it can fall and crash land on the moon surface, we use this thruster. Slowly this thruster was controlling the speed. The speed was controlled. And we had two types, vertical and horizontal movement. Again, remember that we were carrying out both vertical. We use a vertical and horizontal movement to properly land on the moon there. Landing was not like this. You know, landing was not like this. How was the landing was there? I'll draw a diagram. Landing was not like this. This moon surface is there. Landing was not like this. Landing of this Vikram with this thruster, it was not like this. It was not like this. How we landed here? We landed like this. We landed like this. So we were controlling two speed. This control of two speed was there. Control of vertical speed and horizontal speed. So we were controlling two speeds there. Vertical speed and horizontal speed. Like, you know, parabola. You know parabola? Parabola, you know that, like a parabola. Then we landed it here. And it was done all very precisely. Right? We deboosted something called opposite direction. We try to deboost it. And we are deboosting it. And then it just landed on this one. Otherwise, what NASA does? What is NASA system there? NASA simply use the parachute. This one parachute. They use this kind of parachute system. NASA system is like this. But India tried this one. This was our approach. This approach we did. It was indigenous design, right? And we were successful in third, that Chandrayaan 3. Chandrayaan 2 was a failure. Why Chandrayaan 2 was a failure? We were not able to control the speed at the last moment. Right? Last moment का जो speed था, जब वो touchdown करता वहां पर मून को, तो उस समय स्पीड को हम कम नहीं कर पाए. इसीलिए हमारा विक्रम लैंडर प्रज्ञा रोवर के साथ चंद्रयान 2 मिशन में क्रैश हो गया. हम सॉफ्ट लैंडिंग नहीं करा पाए. और जो लेसन हमने सीखा, whatever lesson we have learned in our Chandrayaan 3 mission, we successfully controlled the speed and then we landed on the point there. There we landed it. So you should know this all. See, ये सब बहुत, मतलब I know that UPSC will not ask the question, but मैं एक बात को हमेशा बोलता हूँ ना, understanding is very, very important. You don't have to become an engineer or a scientist or technocrat. वो जरूरी नहीं है. But you should know how we carried out there. It was all indigenously developed and carried out there. I hope this is you all are able to understand. ये चीज समझ में आ रहा है सबको कि what I'm trying to make you understand here. Let me see your chat box here. Yes, Japan also did the same thing. Pankaj is very right. Japan also used the same method. And Japan also was successful to land. Right, JAXA also did the same thing here. Good, very good. So now what I'm coming here, Chandrayaan 2, if you look at Chandrayaan 2 mission. So let me write about Chandrayaan 2 mission. So now let's go to the Chandrayaan 2 mission. Chandrayaan 2 mission here. What are the main points here? The first thing is that when we launched, we were planning for 2018. It was launched in 2019. Right? After 11 years. We got delayed. And एक साल delay हो गया. And we didn't use the PSLV. Which rocket we used? कौन सा रॉकेट हमने यूज किया? GSLV Mark 3. We used GSLV Mark 3. है ना, इसका नाम था M1. That was the name of the rocket. And you know that GSLV Mark 3 can launch up to 4 ton, 4,000 kilogram. Right? That was what we use. And what is another thing here? It had two modules. It carried 2 modules. One was orbiter, which is still working. अभी भी काम कर रहा है ना, अभी भी काम कर रहा है. Orbiter was there. And second was this lander, and within the lander, rover was there. Pragya rover was there. Right? So that is where Vikram lander was carrying inside 6-wheeled Pragya rover. Pragya rover was there. That was carried by the part. So that was what we have done. So where we failed, right now. Failure in soft landing. We were not able to control the speed at the last moment, and we failed in soft landing. And what was our plan? On South Pole. South pole of the moon. Right? So, but in Chandrayaan 3, we were successful. Now here, orbiter had instruments, and this all instrument is working right now. What is called payload. The instruments are working right now. Right? ये instrument आज भी काम कर रहा है, सारा data भी सब हमें मिल रहा है, and we are getting all the services from the Chandrayaan 2 orbiter से, है ना वहां से. तो Chandrayaan 2 orbiter is still working there. So if we come across the Chandrayaan 2 orbiter here, so if you see here this one. So I'll now come to this one. This is the Chandrayaan 2 orbiter payload. These are the orbiter. They are total ये चीज था. एक क्या class. Chandrayaan 2 large area X-ray software and again solar X-ray monitor XSM. क्या काम था इसका मैप करना? Element like magnesium, aluminum, silicon, calcium, iron. Using X-ray fluorescence. Then you can see here another thing. Can you see L and S band? Synthetic aperture radar, SAR. Same as NISAR. Lunar surface. And you can see here first few meters of lunar surface, and you can see what is the presence of water ice. कहाँ पे? Polar region. Polar region of the moon. Then you have this one, IIRS, imaging infrared spectrometer. Again, you can see here, investigate minerals and signature of water, presence of water. Then same as Chandrayaan-1, what is there? Mapping camera, terrain mapping camera, TMC, TMC-2. So that is a 3-dimensional map of lunar surface. Same as Chandrayaan-1 mission. TMC-1, now TMC-2. And then same as Chandrayaan-1 mission, this one, CHASE-2, to measure the lunar atmosphere. CHASE was also in Chandrayaan-1. TMC was also in Chandrayaan-1. We carry on with that. 5 instrument. Chandrayaan-1 had a 12. Here you have 5. है ना? तो ये ऑर्बिटर अभी भी काम कर रहा है. We are still working with the orbiter. ये ऑर्बिटर आज भी काम कर रहा है अभी. Right? This is what the Chandrayaan-2 mission was all about. Correct? Are you able to understand here? So I'm saying your chat box. ये सब याद करके जाना होता है मुझे, लेकिन but don't worry. I'm telling you that don't worry. You don't have to worry now. अब ये इंस्ट्रूमेंट्स के नाम नहीं आएंगे, just to make you understand. इसके नाम वगैरह नहीं होंगे, just to make you understand here. These are the instruments here. Just to make you understand, I'm discussing that. केवल समझने के लिए मैंने ये बताया यहाँ पर, so that you are able to understand it. All right, so now what I'll do here, I'll go to Chandrayaan-3. Chandrayaan-3, you know that it had both the things here. Chandrayaan-3 में we were able to successfully land here, right? Now, मेरा एक question है. I want to ask a question from somebody. I just want to ask a question. Why South Pole? Why we had planned for South Pole? What is so? What scientists see? Water is all right. Ice, water, or mineral, all things are all right. But I want to just know. I just want to know that what is the relevance from astronomy? South Pole of the moon. क्या उसका relevance क्या है? Yes, Shubham Raj. Kindly unmute yourself.
Good morning, sir. Good afternoon, sir.
Good afternoon. See, water is all right. Water and everything is all right. और क्या objective है? क्यों हम South Pole जा रहे थे? जो गए हैं वहाँ पर. Why we have gone there?
सबसे पहले बड़ी बात की सर वो अभी तक अनएक्सप्लोर्ड है. सबने नॉर्थ पोल वगैरह में काफी किया हुआ है ना, साउथ पोल में बहुत सारे अभी नहीं हुए एक्सपेरिमेंट. सबसे पहले वो अनएक्सप्लोर्ड है. और सर दूसरा एनर्जी के रिस्पेक्टिव से सर हाइड्रो मिथाइल आइस साइनेट्स वगैरह है, वो एनर्जी के पर्सपेक्टिव से वो यहाँ पे सबसे इम्पोर्टेंट वो है एनर्जी सिक्योरिटी के लिए. और इसके हाँ नहीं पता सर.
ये तो ठीक है, लेकिन फ्रॉम एस्ट्रोनॉमिकल साइंस आई विल टेल यू दैट. ज्योग्राफी हो गया आप लोगों का? हैव यू डन ज्योग्राफी? Geography in inside the book you have a chapter of universe, our universe. See, science and technology, space technology. When you're reading space and astronomy, from science and technology, you have to connect with the geography. When you study about universe, theories of universe, solar system, you have to connect with that. Okay, anybody in the classroom who had a geography optional or have studied geography, what is the theory of origin of Earth? How the Earth was formed, or how the planets were formed? Planetary system or solar system? Solar system का formation कैसे हुआ था? How solar system was formed? Big Bang theory. Okay, all right. No, solar system का बताना है. Earth, how Earth was formed? Earth or any planet was formed from where? They're formed from where? Sun, no? Said the sun is the source of that. Okay. And how the moon was formed from the earth? Moon और earth का कैसे बनना हुआ? How did the moon form from the earth? Science and technology always explore theories, evidence, bulging out. Okay, Satyajit is saying bulging out. All right. Moon, it said here, the two aspect is there. Let me show you that. Let me show something here. The two aspects are there. I'll draw the diagram. So that's what I've been always saying. Whichever subject you study thoroughly, study properly, with understanding everything, then UPSC GS is simple, is a cakewalk. पहली बार पढ़ना है, अच्छे से पढ़ना है और अच्छे से इस तरह पढ़ना है कि आपको हमेशा याद रहे. ठीक है? Now look at here. The two aspect is there. One is the sun. So one theory says that a part of the sun which broke, right? Which broke here, the part of the sun, and again it broke into two parts there. Right? One, this became moon, and this became the earth. Right? Another theory says that the sun here, this part which broke here, it formed the earth. Earth was formed. And then from earth, right? From earth, another part just broke away. And that formed the moon. Bulged out and then formed the moon. Now the South Pole, why? I'll tell you the why. What is the South Pole relevance of moon? South Pole of moon, right? And particularly the crater or the signature, that can say us early history of solar system. Early history of solar system. Scientists can find out there's something called magma hypothesis. Again, they're going to test theories, right? Early history of solar system. Now, another thing is that from South Pole, this Chandrayaan-3 mission, that is early, this is called magma hypothesis theory there. Magma hypothesis is there. Is hypothesis, not proven. Like here, it's not proven there. If you look at here, if I just take you to this one. अब आप यहाँ देखो आप इसमें formation of moon, right? Magma hypothesis. Again, this all understanding will be done through Chandrayaan-3 mission was there, this one. Moon may have formed after a giant Mars-sized rock hit magma-covered Earth. This magma-covered Earth 4.5 billion years ago, right? Something which collided here. And then this got separated. And early history of Earth 4.5 billion years ago, Earth was in a molten form, in the form of magma. And that magma that got separated from the moon. Again, that analysis will be carried out. And again, if you see here, कभी भी ऐसा चीज, कभी भी आपको डाउट होता है, कहीं भी कोई चीज होता है ना, तो मैं हमेशा कहता हूं कि इसरो के साइट में जाओ. Go to the ISRO site here. And just go to the Chandrayaan-2. Go to Chandrayaan-2 site here. This one. Now this was the thing here. Now Chandrayaan-2, if you go across there. Now look at here, Chandrayaan-2. Now why did we go to the moon? Right? Advancement stimulated. Now see, what are scientific objectives? Now you see a launcher, orbiter, right? Lunar Vikram lander, Pragya rover, right? And when you go down here, in this one, is all given here. Vikram lander, Pragya rover, electric part given here, right? यहाँ बताया गया है सारा जो ये चंद्रयान 2 का मैं बता रहा हूँ मैं I'm talking about Chandrayaan 2 here. Highly complex mission here. Now see here, this one. I'm just highlighting here. See here. मैं केवल highlight कर रहा हूँ. The lunar south pole is especially interesting because of the lunar surface area that remains in shadow is much larger than that the north pole. There could be possibility of presence of water in permanently shadowed area. And now you can see the last sentence. I'll read the last sentence. South pole region has craters that are cold traps and contain a fossil record of early solar system. Can you see here? क्या आप पढ़ सकते हो ये? इसरो साइट में लिखा हुआ है. South pole region has craters that are cold traps and contain fossil record. जैसे हम लोग फॉसिल पाते हैं ना, डायनासोर फॉसिल, मैमथ फॉसिल, एंड वी ट्राई टू फाइंड आउट कि कब वो एग्जिस्ट किया था, कब वो था वहां पर, ऑफ द अर्ली हिस्ट्री रिकॉर्ड. आर यू एबल टू सी दैट? ठीक है ना? फॉसिल रिकॉर्ड ऑफ द अर्ली सोलर सिस्टम. दैट इज अगेन अ साइंटिफिक ऑब्जेक्टिव. दैट इज अ साइंटिफिक ऑब्जेक्टिव. आर यू एबल टू अंडरस्टैंड हियर? सबको ये समझ में आ रहा है? मैं इसलिए इतना डिटेल में जा रहा हूं सो दैट यू आर एबल टू अंडरस्टैंड द थिंग्स देयर कि चंद्रयान मिशन का क्या इंपॉर्टेंस है इंडिया के लिए. और ये सब चीजें ना करंट अफेयर्स के मटेरियल में नहीं मिलेगा, मैं आपको बता देता हूँ. मैं इसलिए बार बार बोलता हूँ कि बाजार में जो आप पढ़ रहे हो ना, बी केयरफुल. हु सेट द क्वेश्चन पेपर? सब्जेक्ट मैटर एक्सपर्ट. They are not the coaching institute content developers, right? They are not the people who set the question. What if any part of the question, something linked with that is asked? तो क्या होगा उसमें? फेल. एग्जाम में अगर क्वेश्चन आ गया ऐसा कुछ भी तो फेल. तो पता ही नहीं है क्यों. करंट अफेयर मटेरियल क्या होता है? सारे करंट अफेयर मटेरियल कॉपी पेस्ट एक ही तरह की चीजें होते हैं. So you need to have good reading and particularly from the government website. इसरो का वेबसाइट बहुत इंपॉर्टेंट होता है. शॉर्टकट से काम नहीं चलेगा. यहाँ क्या चाहिए ना, रेडीमेड चाहिए, स्पून फीडिंग, कि रेडीमेड चीजें मिल जाए, है ना. कोई अच्छा आपको कंपाइल करके मटेरियल तैयार कर दिया है, बस उसको लिया, रट्टा मार दिया, तो ऐसा चीज नहीं होता है. यू हैव टू गो, यू हैव टू वॉक एक्स्ट्रा माइल. और मैं आपको बताया तो दिस ईयर all of you who are going to appear, be prepared. That's what I'm trying to tell you again. Many of you would have appeared last year exam. Don't do the same mistake what you have committed last year. Don't do the same thing this year also. Right? कई बार क्या होता है, आप गलती करके सुधरते नहीं हो. अभी भी रीडिंग रूम में, लाइब्रेरी में वही सब कोचिंग इंस्टीट्यूट का मटेरियल उठा के वही पढ़ रहे हैं सब लोग. एक्स्ट्रा जो एफर्ट है, जैसे इसरो का साइट है, दिस साइट रीडिंग पार्ट, दे आर नॉट डूइंग इट. So that's what I'm trying to make you understand. Ki walk extra, go extra something. And that extra what you do, that's where the question will be in the exam. And you will be the one to solve. बाकी जो 99% जो crowd में है, reading the same stuff, same content, and if something goes outside that, they will fail in the exam. And please don't blame UPSC. UPSC will always maintain the standard. आप लोगों में से बहुत लोग ऐसे भी हैं, पॉपुलर कोचिंग इंस्टीट्यूट के टेस्ट सीरीज के पेपर आप देते हो, and you are taking that Xerox copy from the market, doing the same thing. What is happening? Your limit of knowledge is only up to that. Those test series questions, the model answer, you are thinking about that only there. You are not going beyond. उसके बाहर नहीं जा रहे हो. Test series is a trap. Test series is a trap, right? So Siri has come up. So test series is a trap because your brain get fed by all those model answer and you think there only. And even the simple question, something asked in UPSC prelims exam, you make blunders. तो मेरा काम है आपको जगाना. Be aware. You know the pattern of the exam. What type of questions are being asked? And I believe UPSC is very simple exam. You know who blame the UPSC? They have changed the pattern of the question. They have started asking different question. It doesn't matter. If the options are given 1 and 2, 2 and 3, 1, 2, 3, or the option is given any 1, any 2, any 3, doesn't matter. If you know the question's answer, whatever choice is given, A, B, C, D, you will be one to solve it. It doesn't matter what way the choices are given. You cannot say that elimination has been removed. Right? अब वो नहीं बोल सकते कि ये किया गया. एलिमिनेशन रिमूव करने का और अच्छा तरीका है. वो अगर आपको क्वेश्चन पता है तो आपको क्या मतलब है एलिमिनेशन है या नहीं है. आपको आंसर पता है तो आप तो कोई चॉइस तो कर ही दोगे ना, सही चॉइस. तो आपको तो सब्जेक्ट पे ध्यान देना चाहिए, द टॉपिक के नॉलेज पे ज्यादा ध्यान देना चाहिए. So that is what I'm trying to make you understand. So where you have to read Chandrayaan 2, Chandrayaan 3, ISRO website. I've opened what? ISRO website. Here you have the information. And UPSC will get into this particular information. यहाँ से पूछा जाएगा. ये इसको बेस बनाना है आपको. Are you able to understand here? ठीक है? Now I'll be coming to Mangalyaan there. Chandrayaan 3, again, you know, Chandrayaan 3, we did that. So the Chandrayaan 3, what was it? Chandrayaan 2 was a failure. Chandrayaan 3, we had a soft landing properly there. Let me go to the one more area because so that the time is getting up there. That's what is Mangalyaan. Now we are planning for Mangalyaan 2. So Mangalyaan mission. So what was the name here? MOM, Mars Orbiter Mission. Let me give you the main part of it here. So yes, who will tell me the first facts here? You know that it was all in the news. India being the first country to be successfully reaching to the orbit of the Mars, right? In the very first attempt. This all, and even UPSC asked the question also. So, what was the when we went there? When we reached to the Mars orbit? (2014). Now, what is our scheduled plan? Now we are planning for second Mangalyaan this year, MOM 2. After 10 years, see, 2014, that time. Now, after 10 years, we are planning for second, right? Now, what is second thing here? How did we reach the Mars? So, first attempt, you have seen the movie there. Successful, right? First attempt successful, insertion into Mars orbit. Other space agency, they failed in the first attempt, but we did it here. And very low budget. The budget was very low, right? The budget was very low. Let's look at the budget here. If I take the budget here, the budget is this one. You know the 2000 note, we have Mangalyaan, right? Government, now see here, Mangalyaan. What is the budget you can see here? Mangalyaan was 74 million US. ESA, European Space Agency, Mars Express Orbiter, 386 million. NASA, Maven, 671 million. Nozomi, Japan, 189 million. Phobos and Grunt, Russia, China, 117 million. So if we compare same time, remember the same time. One day before, right? One day before, 23rd September, America's in Marvin that reached Mars. 23rd September, one day before, Marvin was also orbiter. Remember that. It was also orbiter mission. Just like a Mangalyaan. And if you compare the cost, $74 million, $671 million. How many times more? Almost 9 times. Almost 9 times more costly was NASA's mission. Right? If you see here, 9 times costlier, expensive. Then ISRO mission is there. तो कैसे हमने किया? वो फिल्म देखा है ना, मिशन मंगल, अक्षय कुमार, विद्या बालन, all those women scientists, how we were able to reach? इतने सस्ते में कैसे पहुंच गए? Yes, Bhanu, how we were able to do it very low cost? The budget was very low. How we were able to reach the Mars? Bhanu, there's a cost I am given that. So what approach India did? What approach India did? Tell me here, what approach India did that? मैं अभी chat box भी देख रहा हूँ. Bhanu, what we did that? Yes, Sejal is saying off engine when it's heated, switch off and switch on engine. Okay. Rohit Singh has said here, fuel less consumption. Very good. Pragati has given that. All right. Yes, you are aware of that. What we did was this one. You, आप सभी को पता है. I'm just trying to make you understand here. What we did was that it was in 3 phases. What are 3 phases? First was geocentric orbit. Second was heliocentric orbit. Sun's orbit was there. And third was Mars-centric orbit. It will come there. It all will come. वो भी आने वाला है, अभी सब आ रहा है ये चीज. Geocentric, heliocentric, Mars-centric orbit. And it's very true that we have switch on, switch off there. So that was this is the sun, this is the Earth. In 3.5 years, Earth and the Mars are in the shortest distance possible. This is the Mars, not Moon. So what we did first we took it here. Mom was here, just like the satellite. We added here. This is the first phase. Then we gave thrust. Then we gave a thrust. Then we gave a thrust here. This is the second phase. Right, this was the second phase here. Mom was here. Second phase, Sun's orbit. And then what happened? As it went near to this, so we inserted the mom here, the third phase. This was the meticulous planned way by which ISRO was able to send the spacecraft to Mars. Now, same approach we'll do for Venus. You know, Shukrayaan, Shukra. Shukra is the Venus planet. We have also planned for another interplanetary mission called Shukriyan to the Venus planet. Same approach we'll do for Venus also. We have planned for the same thing here. Right? Same approach we have planned for the part of the Venus also there. Then what comes here? You know that fourth point which I'm writing here, that is here is India's first interplanetary, Earth and the Mars mission is this. Right? Now tell me what are scientific objectives here. The fifth point here, it carried 5 instruments. As a payload. 5 instruments. The scientific objective was here 5 instruments were there. I'll go for that one. 5 instruments. I'll write one by one. The first one is called Mars sensor for methane. Detect methane gas. And you know, if methane gas is found, what will happen there? It can indicate the presence of life. On the right planet, it can find out the presence of life. What is the first instrument? MSM. Mars sensor for methane. Mars sensor for methane. Now what is second instrument? MCC. Mars color camera. To image surface imaging. Mars color camera. Surface of the Mars to be imaged there. Then third, what is called here MENCA. Mars exoatmospheric neutral composition analyzer. I'll repeat. Mars exoatmospheric neutral composition analyzer. MENCA. To study outer atmosphere. Exoatmosphere of Mars. What type of gases are there? MENCA is there. Mars exoatmospheric neutral composition analyzer. Exoatmosphere of Mars. And again, fourth one for water is something called LAP, LAP, Lyman alpha photometer. So here to detect water. To detect water. To find out water. LAP. Look out for water in the Mars. And the last fifth instrument, it has got something very, very important. What is called here? TIS. 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 Thermal infrared spectrometer. Again, volcanoes. Volcano, magma, lava, high energy. Here to detect high energy. Sources. Thermal sources. Like maybe some crater, some kind of magma, some kind of volcanic eruption, high energy processes in the planet Mars. So scientific objective is that methane gas, surface imaging, study of minerals of Mars, because Mars is red because of iron oxide. Then again water, then find out gases in the atmosphere, any kind of high thermal event. And we will now carry on further, because now what happened, 2014, 10 years of Mangalyaan, it was planned for 5 years, but 10 years are there. So now what has happened? अब क्या हुआ इसमें? अब उसका काम करना बंद हो गया है, इंस्ट्रूमेंट वगैरह. तो हमें दूसरा भेजना है, वहां पर सेकंड भेजना है. और हम लोग क्या प्लान कर रहे हैं? दूसरा शुक्रयान फॉर वीनस भी हम लोग प्लान कर रहे हैं. सेकंड इंटरप्लैनेटरी मिशन व्हाट इंडिया हैज प्लान नाउ. राइट? तो ये सब बहुत इंपॉर्टेंट है, फैक्ट्स, certain facts with you have to remember that. ठीक है? 2 घंटा बहुत कम टाइम होता है. I wanted to teach you so many things today. लेकिन 2 घंटा कैसे बीत गया पता ही नहीं चला. I wanted to cover a lot of things there, but then I wanted to cover astrosat, exposat, and all other topics there. But let's see tomorrow. Because I'm writing, no, I'm writing and teaching you. That's what it takes time. खाली handout होता, handout. खाली बताता चला जाता तब तो जल्दी हो जाता. Okay, anyway, there are many people are there. Pankaj Singh, the fossil records cannot find in Antarctica region ice also. When fossil record in Antarctica, that can provide also there. But we have to also substantiate with moon also, no? And again, remember that Antarctica fossil, what you were talking about, Mr. Pankaj. Pankaj, unmute yourself. Pankaj Singh, unmute yourself. Antarctica, that also could be the part of it, but how would we know that Antarctica's fossil record? And this, remember that this fossil is not any animal or fossil we are talking about. We're talking about the soil, rock, some kind of a, geological record. So which fossil you are talking about? Antarctica fossil? Pankaj, I am looking at your chat. Which fossil you are referring to? Anyway, he is not able to respond. Good, very good. Very good. Yeah, we can do that. What you were saying is we can do it. Pankaj, we can do that one, but again, we have to cross-refer, no? It's on Earth we have, Antarctica we have, but we have to also see the same thing in the moon also there. Then we can correlate. The moon and this one both are having same. See what Pankaj is saying, Antarctica, there also that record could be there. But let's say we find on the Earth. But again, we have to correlate that whether moon has got the same thing. The two things, Earth and the moon. If both match, whatever we have on Earth and whatever we have on the moon, both match each other. Both are similar. Then we can say that moon has been formed from the Earth. Then only we can do that. Right? Is it clear? Okay, anyway. Now the time is up there. So that's what we'll stop the class. I wanted to cover the space technology today, and tomorrow I wanted to discuss defense technology. Tomorrow I wanted to go for defense technology. So that Sunday test, you may have certain question on missiles and all this thing. Right. Thank you, Pragati. ये तो कुछ नहीं, ये तो मैं ऑनलाइन पढ़ा रहा हूँ. ऑफलाइन का अलग ही मजा आता है. Offline class, something different is that. But you have other subjects also there, and I'm not free right now. I will be free in the month of March. After 10th of March, I will be in Delhi. ठीक है, let's see that अगर मैनेजमेंट के पास टाइम है तो मैं ऑफलाइन आके पढ़ा सकता हूँ. अभी तो मैं बाहर हूँ तो I have to teach online there. But I'll talk to the management. If that is possible, then in that case, offline classes can be done. But again, and whatever time I have got, that the management have to provide me that time there. ठीक है, Pragati, thank you. So Madhvi is also writing here, able to understand. Any doubt you have? I'm looking at your chat box. Majinder Singh is asking question, does price of spacecraft depends on relative PPP? Yes, it also depends on that. Yes, that is true. Majinder, you are right. गौरी शंकर ने नहीं कहा है, तहसीन ने कहा है. थैंक यू सर. सेजल, थैंक यू. Good. You don't have doubt. Mugambo खुश हुआ. अगर doubt नहीं है, thumbs up. Right? Sorry. अच्छा ठीक है. Tomorrow's topic I'll tell you. Tomorrow what I'm going to discuss. Tomorrow I'm going to discuss AstroSat, India's astronomical satellite, AstroSat. We will also discuss X-ray polarimeter, XpoSat. ठीक है. We will also discuss about Chandrayaan 3 का कुछ part रह गया instrument वगैरह कि what type of instruments carried by Chandrayaan 3, Vikram lander and Pragya rover. So we'll go to Chandrayaan 3 mission. We will also discuss about a very important topic, INO, Indian Neutrino Observatory. Right, Theni in Tamil Nadu, part of the very important project we have, INO, Indian Neutrino Particle Research. And I'm also going to discuss tomorrow another very important topic, TMT, 30-meter telescope, Hawaii Island, Mauna Kea. India is one of the partner country in that TMT project. I'm going to discuss in the classroom. All these topics, and then we'll go to some missiles. Agni, Prithvi, those defense, submarines, those areas I'll cover there. That will be our tomorrow's topic. Let me see how fast we can move on. ठीक है, मुझे इतना डिटेल में नहीं पढ़ाना चाहिए. शॉर्टकट भी काम चल जाता. हाँ? नहीं? No? Okay, everybody says. Yes, Nagamani, are you able to understand? Nagamani, you're from Karnataka, right? Nagamani? No? Andhra Pradesh? AP? Okay. Kadapa only? Nagamani, which district? Yes, which district of AP? Now group exams are coming up, you know. Now very soon notification of group exams will be there. Group 1, Group 2 exams. Telangana government is going to come with group exams. Acha, you're from Anantapur. Oh, Anantapur. Good. You're coming from a very good place, right? I have a friend of mine, Jai Krishna sir. He's from the Anantapur. There's a teacher, Jai Krishna. We are a very close friend. And he's from Anantapur. We always talk about whenever we meet, we talks about Anantapur. All right. Yes, Bhanu, Hyderabad. Yes, you're right. Yes, Snigdha is saying that the details that you teach us is to help us understand all things connection. Yes, that's true, Snigdha. You're very correct. Here we have India, right? We see the India. People from all parts of the country assembled together, right? This is what called diversity in unity. Asli Bharat yahan dikh raha hai, right? Yes. So anyway, we'll stop the class. I'll not torture you too much, and we'll meet tomorrow. ठीक है? कल हम लोग मिलते हैं. Tomorrow I'll meet. Yes, management. Any person in the management? Shall I quit? Shall I take the leave?
Yes, sure.
Sure. Who is this? Pavitra?
Sir, Pratiksha.
Pratiksha. Yes, Pratiksha. All right. So tomorrow again, same time, 2 o'clock, we'll meet. All right.
Sure. Thank you,
All
sir.
right. Thank you. Take care. Bye-bye. Right.